Hey everyone, welcome to my talk, Decoding Synthetic Monitoring, a journey from end-to-end UI tests to service level probes. I know it's a very long title, I apologize for that. Whoa, that made a loud sound. So my name is João Proença. I am an expert quality engineer at a company called Øredev, and I come from Lisbon, Portugal, on the other side of the continent. Over there you'll find my Blue Sky handle if you want to communicate with me, because it's one of the platforms these days where I'm most active online. Okay, so the topic that I want to talk about today started with a problem that existed within my organization. Okay, so we have, of course, we have our own product. It's within healthcare. We're a tech health company, but it doesn't really matter the nature of the product itself. We had a on-call team, and we still have an on-call team, which was basically a group of individuals within our organization that are making sure that the application is up and running and behaving correctly at any given time of any given day. So there are a team of 24/7. They're looking at problems that may exist in production, and they might be, waking up in the middle of the night with pager duty alerts and stuff like that. If there are problems that are detected by our automated mechanisms and our observability tools and whatnot. We had a problem back then, which was usually with these tools that give you alerts, you need to have traffic coming in from your user base that's generating events and data points that then tell you if something's wrong or not. But given the architecture of our product, there are certain parts of it that have this kind of like single-tenanted nature, where essentially we are deploying specific services dedicated to specific clients. Those clients then have their own user bases, but the traffic that they see is highly fluctuating, in the sense that maybe people use the system extensively throughout the day on a weekday, but if you arrive on a Sunday and it's like 1 a.m. on their specific time zone, there's not going to be a lot of traffic or no traffic at all, and then we're kind of like blindfolded to any problems that may be happening during those periods, because if there's no traffic, there's no events, and we don't know if something's off. Okay, and this, while our on-call team was doing a good job, sometimes some of those problems took a while for us to figure out that they were happening because of these situations where there was little to no traffic. So someone had a bright idea back then of, okay, if we need this, the little amount of traffic to check if the system is up and running at any given time of day, we have these amazing testers around, myself and even Vernon back then. We have these amazing testers around. They've put together these really good end-to-end automation, automated tests that go through the UI and exercise the core use cases of the system. Why don't we repurpose those to exercise the system in production every half hour? Okay, and so they put that together, and that really served its purpose, because all of a sudden we have that, that little bit amount of pulse that would tell us if the system is up and running and is basically creating the events in production at any given time of day, to make us, confident that everything's working correctly. Ta-da! Okay. That strategy proved to be so useful that they even ended up going into a point in time where they decided that not only we would be alerted by any sort of errors or any sort of signals that we could get from the production data in our observability tools, they also decided that if those tests, whenever they were running, because they're exercising core use cases of the product, if they failed, then we wanted to be alerted right away, the on-call team, and being woken up to check if something bad is happening or not. While that, it's useful from being in a high state of alert and understanding really quickly or addressing a problem really quickly, it's very good in that sense. It can also become problematic with UI test automation, because those kinds of tests tend to be flaky. Now, So test flakiness, of course, within automation means that you have a test that most of the times it's going to pass if the system is working. It's not going to pass if the system is not working. But if there's a little bit amount of flakiness, sometimes you might get some false positives just because something became a little bit slower or because there's a part of the automation that's not sturdy enough to handle all of the different situations. I've had a vast experience with UI test automation and other forms of test automation. And I will say that while you could build, if you invest time and resources in building very stable UI tests, there's always a little bit of flakiness that goes into those sorts of technologies. There's always like something around the curve that you're not going to predict that may make your test fail in a situation when nothing's wrong. And when you are exercising those tests in production and you are waking people in the middle of the night, it becomes a really bad problem. Because a test that's flaky like once every 100 runs, it's perfectly good probably for if you just exercise them when you're releasing something, and you can just rerun them to overcome that problem. But if you're running them every half hour on any given day, that amounts to hundreds and hundreds of runs throughout the month, and at the end of the day, it will eventually fail due to that flakiness, and then that lowers the confidence that people have on those tests as a monitoring approach. So this was our problem. We were doing a very good job in terms of on-call and in terms of responding to the problems that we had in production, but the on-call members were kind of miserable because they were being woken up at night on a Sunday or on a Saturday because of something that the test evidenced, but at the end of the day wasn't exactly a problem. It was just a little bit amount of flakiness. And we set out, okay, it's time to change these things. And this was something that was dear to my heart. So I thought, there's got to be a better way of doing this, right? So why are we even using UI tests, automated tests in the first place to do monitoring? That doesn't feel right, okay? So the first thing I did is okay, let's research what other folks are doing around there. And then I found out that this thing has a name. It's called synthetic monitoring, okay? And the first definition of synthetic monitoring that I found is that simulating user interactions to assess how the system behaves in production. Okay? It's a form of active monitoring rather than passive monitoring. Usually when we just say monitoring, people are thinking about passive monitoring. You're getting real traffic coming from the world, you're monitoring that traffic, and you're getting as much as useful information that you can get from that traffic. With active monitoring, you're actually injecting traffic to your system so that you can have another sort of signal that's also useful for you. Another definition I saw is that was around automated scripts that mimic predefined user paths to evaluate availability. Is the system up or down? Which was definitely something that we were doing. Functionality, our transaction success. Once again, something that we were doing because we were exercising use case from start to finish. So this kind of approach also not only told us if there were any errors happening, but it also told us if all of a sudden you can go from step 3 to step 4 in a core use case or something like that. And also performance. We weren't as, attuned to the performance problem here. We weren't paying that much attention to or it wasn't like the big requirement there. But we ended up also understanding a lot about the performance of our system by using this because we just got the performance data for free while doing this approach. So we're talking about response times, the latency of all the requests that are coming out. Okay, so now this thing had a name. It's a niche area within monitoring and observability, and it's called synthetic monitoring. But then I went out, let me figure out what people are doing out there and what sort of contents, best practices and whatnot exist out there. And it was kind of frustrating because at least then, this was like a year ago or so, or 2 years ago, I started looking into the synthetic monitoring world, and mostly I would find content coming from vendors, where they put this sort of functionality into their tools, and then they're trying to sell it to you. Of course, they're trying to explain what synthetic monitoring is, but I didn't see a lot of people talking about their experiences and what they would advise other folks to do. But I did find some people talking about reasons why you should do synthetic monitoring, which also hints at reasons why you shouldn't be doing synthetic monitoring. Maybe this is not for everyone. And I got like three main reasons why I see folks doing synthetic monitoring. Some of them were our own. The first one is, of course, if you have systems that experience low traffic or highly fluctuating traffic. I've already explained that. It was our situation. The second one was distributed systems with hard-to-trace end-to-end journeys. So maybe you do have a lot of traffic, and it's happening all the time, but you're getting all of these different events, and it's really hard for you to, collate all of those events and to understand a single user journey throughout your system, and being sure that the core use case can be exercised from start to finish. That's also a situation where having synthetic monitoring can be really useful. And then another one, which also was also a problem for us, and it kind of relates to the first one, was whenever you have ambitious service level agreements. So service level agreements, if anyone doesn't know what it is, essentially you have a contractual agreement with your own customers or clients where you state what the level of service is going to be. Usually there's something like, I'm going to have 99.95% availability with my system, meaning that the system must be available for 99.95% of the time given a specific month. Otherwise, there will be contractual penalties because you didn't conform to that. Why is this related to the first problem of the low traffic and highly fluctuating traffic? Imagine that your system isn't that exercised on a Sunday. There's a user that comes in at 1 a.m., they use the system, everything's okay, and you got evidence of that. 12 hours go by, and another user comes in at 1 p.m., they try to exercise the system, and they get an error. All of a sudden, if you want to measure how long the system was down, you have a 12-hour window where you can't state anything because the frequency was so low that you don't know what happened during that period of time. But if you start doing synthetic monitoring, you get a lot of data points throughout those 12 hours that maybe will tell you, well, the system was only down for 5 minutes or for 30 minutes because we have evidence that it was up and running every half hour or every 5 minutes, whatever you want to set it, in between 1 a.m. and 1 p.m. Okay, so I already understood the what. It's called synthetic monitoring, the why we should be doing it or not. But then I was like, okay, but I'm interested about the how, because we're using UI automation for this, and I don't really understand if that's a good idea. Once again, this was a frustrating topic because when I started seeing experience reports from other folks in talks and whatnot, they were doing exactly the same thing. They were telling me these stories of, hey, we have these end-to-end automated tests that go through the UI, and we just repurpose those to do synthetic monitoring. And that was awesome. And I was like, oh, I don't think it's a good idea. And here's why I don't think it's a good idea. Here's why the fundamental problem with this approach in my mind. When you're doing synthetic monitoring, there's a part of your system as a whole that you run and that you want to target with this sort of approach. There's another part of your system that you don't run and you don't want to target, but you're bringing it to the table nevertheless. What do you actually want to monitor? Where in a system such as ours that has a service architecture and whatnot, you're running assets in a cloud provider like Google Cloud, AWS, or Azure. You're offering, you have databases, you have services, you have automated scaling if traffic is coming in and there's a surge or something like that. You're offering APIs to the world to be used by other components of your system as a whole, or maybe you have events that are being sent out or you are receiving events, and this is the part that you actually run and you want to monitor for because you can do something about it in production. You are operating it. But then there's a part of the system, in our case, which is more closer to the front end that you're not actually running even though you own it. And I'm talking about in our case, it could be a web application, so it could be all the code that's running within the JavaScript code running on the browser side. It could be a mobile application, so it's all the code that's running in some person's device. That's a part of your system. It's actually a pretty, let's say, significant part of your system, but you're not exactly running it. It's running it in an outside device, let's say. Now, I'm not saying that you shouldn't monitor for that, but usually the problems that you are monitoring for that part of the story are problems like well, maybe this is not working for a really old browser version that some people are using in Canada. Or maybe it doesn't play well with a mobile device that's really popular in Indonesia. Okay, those long-tail problems, you want to know that they're happening in production, but you won't find them with synthetic monitoring, where you're basically, always exercising the same browser or the same mobile device or whatever. But there are systems that are good for that, like tools like Sentry and whatnot that just call back home saying, hey, this dude was using this weird brand's manufacturer and all of a sudden the thing didn't open up and you should know about it. But you're not covering that with synthetic monitoring. And not only that, because you are exercising the UI and the front end, you usually need to use frameworks like Selenium or Cypress or Playwright or Appium that allow you to simulate what the user would do through the UI. And you're also bringing that to the table on your synthetic monitoring setup, meaning that this whole thing isn't that interesting to you from a monitoring perspective, but it's giving you a lot of problems. It's giving you flakiness, it's usually slow. Usually when you build the UI automated test, it's something that will run over minutes rather than seconds. And that's also a big problem, and I'll explain why. So essentially what I wanted to do was just figure out a different way of doing this whole bit. Now, usually I need this slide when I go to a testing conference. Maybe it's not that relevant here, but wait a minute. Are you telling us that you're a quality engineer and you're telling us not to use test automation frameworks for a problem? No. And actually, I'm not against UI automation at all. What I think is that UI automation can be really, really useful when you're testing your system out and in those situations. Meaning, we are releasing something new. We are changing a configuration. We are doing changes to the system itself. Those are the right moments to come in with UI automation to cover it as a whole. And in our specific scenario, we do that, and it's very valuable within our organization. We rely on a bunch of end-to-end UI automations in the overall testing strategy, and they have proven to be really useful whenever we are changing the system for whichever reason. But using it for production has given us these problems that we wanted to solve. Maybe some of you folks are already doing the same exact thing, using UI automation for production monitoring, and that's fine if it's working for you, okay? But this talk is about, let's consider a different alternative that we actually ended up, putting into place. Okay, so the way I went about how we could do this differently was I started having conversations with the head of our SRE at my company. And I explained the problem, and I asked him, look, imagine that you're in a perfect world. How would you set this up the way that makes sense to you? And the person started telling me about something called Prometheus probes. Okay. Now, even though it's called Prometheus, and Prometheus is one of the tool vendors, it's actually not bound to Prometheus as a tool vendor. It's more of a standard that you can set up with other sorts of tools. We're not even clients of Prometheus. We use Honeycomb, and we set the same thing up using Prometheus probes, even though we use a competitor. Nevertheless, the idea here is that you have Prometheus, which is like an observability tool, and you're going to set up a probe. Okay, you have Prometheus over there. It's the place where we store the data and where we navigate the data. There's going to be something within that's going to call a probe every X minutes or every X seconds, wherever you want to do. It's going to use something called the multi-target exporter pattern, which is a very long name, that basically means it's this common language or a standardized language to talk to probes. The most simple probe I can tell you about is something that Prometheus offers you out of the box as an open source project called the black box exporter. And it's essentially something where it's going to make an HTTP request to that probe, and it's going to tell you, hey, please check if that website over there in blue is up and running. Okay, it makes a call, HTTP call to the probe. The probe knows, okay, if I need to check that website, I'm going to do an HTTP request to that website. I'm going to wait for the reply to come back. I'm going to check if it's a 200 status code. I'm going to check how long it took, and I'll report that back using this language to Prometheus. And then I'm doing this every X seconds or every X minutes to collect data in a timely manner. Okay. Now, this is, Okay, in our case, we weren't using Prometheus, as I was saying. We are actually using a tool called Honeycomb, which I'm a big fan of. But we are using OpenTelemetry collectors, which I don't need to go into big detail. It's just kind of like a standardized framework that folks use to instrument code and to collect data from production in a way that's kind of agnostic of vendors. So you could just set up OpenTelemetry collectors and use OpenTelemetry to instrument your code, and then you can just send that data to whichever tool you're using for observability. But we use an OpenTelemetry collector to do that function of every X minutes I'm going to contact that probe over there, and then I'm going to pick that data and send it to Honeycomb for the humans to do whatever they want to do with it. Now, what the SRE leader was telling me is, well, this thing over here is very simple. It's just an HTTP relay. You're just telling it, please see if that thing is up and running, and with a simple HTTP request, and tell me if it's, and report back to me. But what if this thing, instead of doing that, was a bit more sophisticated? What if what it was actually doing is not do just one HTTP request, but several in sequence, mimicking what the request that would be done coming from the front end in a full use case. So essentially what he was saying was, I don't want to have this thing over here. I want to replace it with a Prometheus probe that simulates the same thing, but at the API level. So it's basically replacing the whole front end and mimicking what the front end would do from the perspective of the API over here, which is the thing that I actually want to monitor. And then we started having conversations on, now we need to set up a framework within our organization that allows developers and different teams to build these sorts of probes easily against our system. Immediately, I had a problem there. It was more of a socio-technical problem, let's say, because within our organization, we have different teams that sit within different contexts. They own different parts of the product. Some of those parts are different in terms of technological nature. Some parts of the product, some of those teams work more with front-end technologies. And I'm talking about, they exercise JavaScript and all of the adjacent technologies around that. Some other teams are more back-end in nature, and they're doing Kotlin with databases and whatnot. And so we've always had that problem where if you build a framework that's more front-endy in nature, the front-end teams are going to be really happy about it, but then the back-end teams are going to be reluctant to use it because they're not familiarized with that sort of technology. And if you do, and vice versa, same problem. If you build two frameworks, one for each, then I have a problem because I need to maintain two different frameworks that solve the same problem. But I started noticing one thing, which was there was this kind of like, language and common ground between all of these teams that no one was talking about. All of them were using something that's really common to work with APIs in general. Applications to test APIs, API testing applications. The most famous one is Postman. We don't use Postman because we prefer an open source counterpart called Bruno. But back in the day, I even remember using something called SOAP UI, which I don't know if folks are still using that or not. Someone in the back, there you go. So, but just to get a feel like, if you use any of these tools, can you please raise a hand? Okay, so a lot of people here use them. We're talking about, guided user interface tools, easy to use, that allow you to, make requests to your APIs and test them out, or even while you're developing. And that was key. This was basically a ubiquitous language within the organization, in the sense that all of the teams were using Bruno. Before we were using Postman, but by then we were using Bruno to test out the APIs that they were building and that they were changing. Even better, teams tended to create these collections of requests that simulated what a regular use case would look like from the point of view of the API, and they were committing those collections within the repos of the services themselves. So we already had, subject matter to tap into to build the probes that we wanted. So the idea that I had, at least in my context, I wasn't the only one with this idea, and I'll explain why. Well, instead of having a black box exporter, I want to create a Postman probe, or in our case, we call them Bruno probes because we were using Bruno. Meaning, what the probe is going to do is that I don't want developers to be thinking about what a probe is or not, but I want them to provide me or provide us with collections of requests that simulate a full user scenario that tells us that the system is healthy from an end-to-end perspective, and then I can just very easily fire up a probe that has those collections within it, and I can just tell it, hey, please go to that target there. It could be production, it could be in a specific context, and exercise this complete flow, which is a sequence of requests against it. Okay? And this allowed us to basically create these probes very easily because developers and teams were only concerned about the API interaction and not the whole thing that went around to create the data that we needed. I told you that I wasn't original in this idea because once I started researching how I could do this, I actually found that for Postman, there were a couple of folks out there that had the same exact idea. And so you can even go to these two links that I can share later on of folks that created open source projects that essentially do the same for Postman. Bruno is not that well known, so maybe I was the first one to tap into that. But for Postman, there's already stuff that you can use open source if you want to put in place the same sort of thing. And I even think one of these projects were made by a couple of folks at Google. Okay. I've done a lot of theoretical stuff and whatnot, but let me try to explain what I've just told you with a practical example, okay? It's not a live coding exercise, but it is a demo. So I'm going to use a very simple website provided by our friend, Mark Wintrigham, where it's essentially just a test application that anyone can go to if they want to, they want to learn about test automation frameworks or they want to do exploratory testing on a test app. And you can find it at automationintesting.online. This is a bed and breakfast page where essentially you can go there and you can, check the rooms that are available. You can book a room, provide your information, that sort of thing. And folks use this for, to do testing exercises and whatnot. The first thing that I did was that I created an automated test that's going to exercise. I'm using Selenium, which is just a framework that sits on top of Selenium. And the thing that my automated test is doing through the UI is that it's going to the calendar. It's selecting 2 nights to book. There's a price over there. It's putting in my personal details, and then it's performing a booking. Cool, I have booked a room for me, and now because I want my test to clean up after itself, I'm going to go into a back office, log in, and I'm going to delete that booking from the database. And this is the scenario. It essentially it's mimicking a core use case, which would be someone goes onto the website, they book a room, and then an administrator goes into the back office and they cancel that reservation. Okay, now let's see how we can translate this into all of the requests that are happening in the background against the backend. And of course, that I run the automated test till the end, and then I check the network tab in the Google Chrome developer tools, and I can see all of the requests that are coming out from the front end to the back end that I want to use to set up my probe. Now, the thing that's cool about moving this into a tool like Bruno or Postman is that you can actually go into each one of these requests out of your browser and select to export them to curl format. So curl is basically a tool that you use in the terminal to make HTTP requests. When you export them here in curl format, you basically get a command line that you can just run, and it will do the exact same request with the exact same headers and the exact same information regarding payload and whatnot that simulates the request. Then you can go into Bruno. This is what Bruno looks like. It's kind of like similar to Postman, which I believe is a bit more commonplace, but this is what it looks like. You can just go into a tool like Bruno or Postman and import the curl curl formatted request into Bruno, and you start for something that was exactly the same thing that you had in the browser, and you just need to adjust one or two things. And so I did that for all of the requests that I saw coming out of the browser, and now I have the whole interaction that I had in the UI expressed as a Bruno collection, which is a sequence of requests. Each one of those requests is gonna state all the headers that it needs. It's gonna have the URL. You can see the payload. In this case, it's like the post request that I'm making when I'm actually doing the booking of the room. And you can see that my data is there, the check-in date, checkout date, my personal information and whatnot. I even ran the request and I got a 200 over there. And then in Bruno, if you run this thing as a collection, you will see that you run all of the requests in sequence, and it's really fast. It took like 3 seconds to run the same scenario I've demonstrated while I was running the UI automated test, which took like 30 seconds to run or something like that. And that's going to be very important later on, and I'll explain why. Now, I take that collection and I bring it to my Bruno probe, meaning I just configured the probe to have that collection within its knowledge base. And now I can tell the Bruno probe, I'm using a browser just because it's easier to visualize, hey, probe, please go probe a target that I called AOT, automation in testing, meaning Mark's website. And then I have a configuration within the probe that tells it, well, whenever they tell me to probe this specific target, what I'm going to do is run this collection against this specific URL. And this is I'm not going to go deep into the mess that you see here, but this is the multi-target exporter pattern that I was talking to you about, which is the language that then something like the OpenTelemetry collector and Honeycomb is going to understand. I can tell you that there's a lot of metadata here, but there's something called probe success over there, and there's a value of 1, which means that the probe was successful. There's something there telling me that the probe took 3.23 seconds to run. And then I have the same sort of data about each of the steps, meaning each of the requests that happened. And I'm collecting, success status for all of them, time status, for how long they took for them to run. And I'm even including some custom stuff, like, for instance, a common run ID that will allow me at a higher level to pinpoint all of the things that happened throughout the specific run of this probe. And then we take this and we fit it into a tool like Honeycomb. And this is the kind of thing that you would observe, not about, Mark's website, but something of our own. We start, getting this information into Honeycomb, and we are targeting our systems every half hour, and then we are collecting it in a time series. We focus on a few metrics. We are looking for probe success and failure. We are looking also a little bit into performance whenever we need to troubleshoot something. But then one thing which is really, really powerful about this approach is that you get everything within the same place, meaning we have backend traffic metrics and failures that you can correlate directly in the same place. What I mean is, not only do we have the probe sending data about the probing into Honeycomb, but we also have the backend services instrumented to send their trace data into Honeycomb, and that gives you a very good opportunity to correlate both things directly. Meaning, if I want to look at a specific request made by the probe, I can go into the probe data and then go deeper into whatever information and events I got from actually running that request through the service itself. And this, I will explain why this is really, really powerful with an example. There was a moment when we were setting this whole thing up when we had 2 teams at the organization, or actually we had a team in the organization that were paying a lot of attention to the UI tests that we're running every half hour, not against production, but against the test environment, the staging environment. At the same time, myself and a colleague of mine, we had put the probe approach working against the same environment, and so we could, compare the 2 approaches to see if they worked or not. And there's a specific moment in time when all of a sudden, both the UI tests running every half hour and the probes running every half hour failed failed at the same time because something was up with the system. And what me and my colleague observed, just looking at the probe data, was, look, the probe failed. It's telling me that it failed on step 3 or step 4 or whatever. I can see that all of a sudden there's like a spike in the performance. Like all of a sudden there was a request regarding a report generation that usually took 4 seconds. Now it's taking 30, and that feels like a timeout already. I can immediately, within the same tool, go into the trace of the request in question. I can see going downstream, and I see that there's a PDF generation library that is blowing up with an exception, and it's taking 30 seconds to blow up in that fashion. So it's misbehaving. It probably has a memory leak or something like that. Within the same time frame that we qualified the problem, I had the people that were looking at the test, and they were kind of like, okay, something failed in Jenkins, and now I'm looking at an exception, and I'm looking at the stack trace, and now I'm looking at the code to understand the place of the code of the test where that thing happens, and then I'm now looking at Honeycomb to see if I can correlate this specific part with whatever failures we might identify there, and they were still in this loop while we just went to them and say, hey, the PDF generator is malfunctioning with this exception. We need to figure this thing out. And that really showed us how, from a troubleshooting perspective, this was way more powerful, because I usually use this expression, hopping means friction in observability. And whenever you need to, hop between different tools and different contexts to troubleshoot something, it's going to be hard cognitively for you. And some people even give up, I'm just going to run this thing again and see if it passes so that I don't need to take care of it. You know what I mean? And this actually also taps a little bit into something which I think is really important in the observability world nowadays. This is a quote from Charity Majors that she says that observability 2.0 has one source of truth. Now, Charity Majors is a very well-known figure within the observability world. She's also the CTO of Honeycomb, and she's one of the persons I look up to the most whenever I want to learn more about observability. And this new, second iteration of observability, essentially she advocates that we should have one data source in one place and then several views of that data source. Having a system in place that allows us to, put together not just the monitoring data from our system, but also the probing data is way better than having a signal from some automated test over there that is feeding into a system and then backend data over here in a completely different system, and all of the hurdles of having to understand both in relation. Which is exactly what I just said. Now, so just as a final remark, with great power comes great responsibility. I'm not going to use this quote. What I actually want to say is that with great speed comes great flexibility. Remember when I told you how important it was to look the difference that you had between, running a UI automated test that takes like 30 seconds or even takes minutes, which is actually what it takes when we're running them against our system in production, versus having a probe that runs in seconds, is that from a monitoring and an alarms perspective, it opens a bunch of new possibilities that you didn't have before. Because imagine if you have, which is our case, over the span of half an hour, you're running a bunch of UI automated tests against production to check if something's wrong. One of those tests fail. We need to design that system to immediately wake someone up. Because if we're going to, let's see if they retry the test itself, will it pass? Will it fail again or not? If we do that, that might be really expensive before you decide to wake someone up, because it took after 2 or 3 runs it ran, maybe you're already an hour in to the failure, and that's a lot of time for something to be down in production. And so you wake the person up, and a lot of times they're going to go and they're going to look at it, they're going to run it again, or even run it manually. Everything's okay. They're going to go back to sleep, and then they'll check the problem the next day because it was something that happened momentarily. However, when you have probes that take only a few seconds to run, you have more options. You can, decide that you're just going to wake someone up if 2 out of 5 fail, or if 2 out of 3 fail. You can set, more sophisticated alarms that, that still will, let you know that something failed, but it only failed momentarily, so you can just check about it the next day and you don't need to be woken up. And then if it's still prevailing, if it's happening more than once, yes, then you hit the PagerDuty button and you call them up. So we're almost on time. So just to wrap things up, main benefits of the new approach, of course, that having the probe plus the backend data in one place is a really big plus. Shorter times to troubleshoot. Faster probes means better frequency, as I just said, which allows you to have more sophisticated alerting and better frequency whenever you're checking for problems. This thing is not working. In our case, there was also a benefit that we weren't expecting initially, but then it became really important, was that the UI test automation suite that we had was owned by one team, and they were really, really frustrated about the fact that we built these things to help us with our testing and our releasing. Now they're being used for monitoring, and we need to own this piece that we would like to evolve to something else, but we can't because they're still serving the function of monitoring. And then there's kind of like there's conflicting requirements for why would you would use that UI test automation because monitoring is coming to play and whatnot. Oh, sorry, I spoke about this over here. There's also the part where a thinner automation layer really solved the problem about the flakiness. Usually no one's going to tell you, well, the probes are flaky. No, the probes are not flaky because it's such a thin layer. It's just a sequence of requests that you're making to the backend that if something's failing, it actually failed in the backend. So that really got stability and more confidence about the system as a whole. Thank you. Whoa.